All right, everybody, and welcome to the Daily Space Weather. Let's blast this thing out before the sun blasts out an X-class solar flare. We'll talk about what's going on, what's about to happen, and CME incoming forecasts, and lots more here at the Smash News Network, least busted name in news. By the way, I'm your host, Dan, a.k.a. Smash-O-Mash. If you're new to the channel, welcome to the most comprehensive daily space weather and most detailed solar imagery you'll find in the known universe. This is a 24-hour video from SDO. We put together 211 plus 171 angstroms because it shows great detail for the lower corona as well as the extended corona. There are a couple of new sunspot groups that have recently formed or risen. First of all, two new large groups just rose in the east, one in the northeast, one in the southeast, and another one formed right down here somewhere, right there. There's a new sunspot. It's a small one, but a new sunspot nonetheless. So while this large sunspot down here does have some capability to produce large solar flares, it looks fairly magnetically simple at the moment. The group over there in the southwest is currently the most likely place to see an X-class solar flare or additional M-class events. Here's a close-up of that. That is the most active region on the closest star. So again, don't be surprised to see an X-class solar flare from that, as it becomes statistically more and more likely as it approaches the limb. Let's talk about the channel for a brief moment. We've gone to great lengths to make the channel sustainable. So that's why we have paid affiliate links. You can find them below the video in the description. Today's featured product is Cameron's Coffee, the Cameron's Organic Scandinavian Blend Whole Bean. It might seem expensive at $23.38, but that's for a 4-pound bag. That is not expensive at all, especially for organic whole bean coffee. Check it out at our Amazon shop. The URL is amazon.com/shop/smashomash. Thanks to everybody who's picked up products via our links. Another paid affiliation is our Hemp Lucid shop. Links below the video to that as well. So if you are a Hemp Lucid shopper, or if you're considering trying the products, why not shop via our links and help support the channel that way? Thanks to Hemp Lucid and all of our paid affiliation sponsors. Again, links below this video, and you can also find them on the homepage at smashomash.com. By the way, the cedarwood body balm smells just great. I've got some in the bathroom right now. Today's featured product is all of them from the Red Bubble Shop. We've decided to do some bandwagon advertising today. We've placed our products in order of best selling. So many viewer requests there, represented by various different designs. Some of them rather inflammatory, some of them just for the sake of humor. So check those out, and check it out. There's been a shakeup in the most popular design. Doing some bandwagon advertising there. The most popular design is, indeed, the Do Not Pole Vault the Caldera, and Universum Libertate has moved into second place now. So the Galactic Federation Special Forces. That'll be today's featured product. Available on various different things. Thanks to everybody once again who has picked up merch. That does, by the way, include our URL on the key right there. The key, the symbolism representing signal strength and integrity. Of course, all unit patches are symbolic. The Galactic Federation Special Forces, an example of that. Now, if you're not familiar with our channel's mission, it is our .com's mission as well. You can read all about it at smashomash.com/forum/mission. Basically, it's to assist, study, and report on the ongoing formation of a unified theory of physics. And keep in mind, folks, a .com's mission can be as broad as we want. We can do whatever we want for a .com. Our soon-to-be-formed nonprofit organization has a much narrower mission. So it's also to raise the awareness of the general public of the relationship between space weather and Earth effects, like Tamitha Skov. We're taking space weather mainstream. Also to connect and consult with media organizations and multiply our reach via videos like this one and other outreach processes. If you'd like us to do some speaking on your YouTube channel or whatever, drop us a line. To demonstrate cutting-edge proof of concept solutions to problems, we're growing potatoes in the living room right now. To publish scientific papers in a multidisciplinary manner, we're interested in papers including but not limited to things like spectroscopy, chemistry, astrophysics, longevity, and more. To assist mankind by advancing the study of predictive phenomenon, to optimize value, reduce risk and liability, save lives and resources, and adapt no matter what the adversity is, and of course to not be ossified in our beliefs, and to treat those who are with love, respect, and inclusion to the scientific discussion. The .org's mission will be simpler. You can read about that on the forum as well at smashomash.com/forum. It's completely free for all. There's some interesting data archived in there about everything from cosmology to scamdemics. Here's the .org's mission. It's to advance science via heliophysics, which will in turn advance not only cosmology but also human technology, both on Earth and beyond. So we've leveraged ourselves where we are for obvious reasons. These changes will enrich humans with greater capabilities, a more sustainable future, and via enabling new technologies. So superionized materials, if you've never heard of them, you will soon. It's coming. Again, you can see all the links to the social media accounts and so forth at smashomash.com. And welcome to the Neo-Renaissance. Let's go over volcanoes. Fagradalsfjall is still erupting. There have been some changes that have happened in the lava field at Fagradalsfjall, and we're going to show that here in a minute. First, yesterday plus today from SDO. There is the SDO intensitygram. Again, at least one new sunspot group formed right here. A little tiny pore opened right there, and a new larger sunspot just rose up here. So at least two new groups as this group sets. Here's our colorized magnetogram, also depicting yesterday plus today, August 2nd and August 3rd to date. So that's the scenario. We'll get back to more in-depth information about that. And here is the current live cam at Fagradalsfjall. So it looks like part of that cinder cone has collapsed. It does look like that eruption is sort of slowing down here with time, although there is obviously still some active lava flow happening there. Perhaps a second crater opening, it looks like, maybe. So some changes happening there at Fagradalsfjall. We'll just leave it at that. Stromboli is continuing to explode, although the effusive activity has largely ceased. So that's a crystallization process is now happening at Stromboli. But there still are some Strombolian-style explosions happening there on the Aeolian Islands of Italy. So there are the updates on the Recanese Ridge, the Fagradalsfjall complex. Abico is producing a 12,000-foot ash plume over Paramoshir Island. It's a flight level 120, flight level 060 over Halmahera, Indonesia, as Ibu explodes. 6,000-foot ash plume over Halmahera. East Java, Indonesia, seeing some explosions of Semeru as it produces a 15,000-foot ash plume, flight level 150. Dakono, flight level 070. Another Halmaheran volcano. Popocatépetl exploding in central Mexico, now back on the list, flight level 200, 20,000-foot ash plume over Popocatépetl. 19,000-foot ash plume over Sangay in Ecuador. 15,000-foot ash plume over Revenador in Ecuador as it explodes. It's a flight level 150. Not sure about Sabancaya, but continuous ash emissions from Ubinas in Peru are a reminder to not pole vault the caldera. It could be unhealthful. Next, looking at seismic activity, and here is the situation for the past 90 days. That's volcanodiscovery.com's convenient 90-day bar graph. The largest quake of the past 24 hours was a 5.9 off the coast of Panama. There is the location of that. That 5.9 was at 1:25 this morning. As far as other quakes of 5 or greater magnitude, quite a few quakes here on the coast of the U.S., the west coast of the U.S., no surprise there. None of a 5 or greater magnitude, though. So continuing up the list here, it's been pretty quiet. Looks like only one 5+5 or greater magnitude earthquake here in the past 24 hours. Just that 5.9 off the coast of Panama. Just remember, folks, that any earthquake can be a foreshock. And let's get to some more space weather stats here, as we don't want the video to be too lengthy, so it gets on your screens in as timely of a fashion as possible. So 10.7 centimeter radio flux now at 173 solar flux units. It's actually kind of surprisingly low. We had a huge number of sunspots there and kind of a low radio flux. So your guess is as good as mine as far as where the radio flux is going to go next. You could also note this ongoing upward trend of the sunspot number. See that? That is an upward trend, folks. If you think the sun is shutting down, you should probably exit that cult. That is not a good cult to be in, folks. Because anybody who's claiming that we're seeing a grand solar minimum happen is clearly deranged. Deranged. This solar cycle likely to exceed solar cycle 23, in my opinion. Only by a tiny bit, but if it's even comparable to solar cycle 23, it is the exact opposite of a grand solar minimum, sort of a stronger cycle, actually. Now, let's talk about NOAA and NASA's forecasts for coronal mass ejections. Yeah, coronal mass ejection forecasts. NOAA's forecast is looking a little wishy-washy here. They're forecasting an impact late in the day tomorrow and then into the 5th. We're forecasting an impact somewhere around midday tomorrow and another one late in the day on the 5th or early in the day on the 6th. So that's a little different. Here's NASA's forecast, and it looks like NASA only has tomorrow's CME impact modeled. It is quite earthly directed there, so Earth could see some significant CME core activity. In fact, it looks like the densest core NASA has modeled directly toward Earth. So that's exciting. We could see some significant aurora at mid-latitudes. We're hoping to see some aurora at mid-latitudes. And that is again tomorrow evening on August 4th, and possibly on Saturday evening as well. So Friday and Saturday, organize your aurora parties. There is a significant possibility that you'll get to see some. So here's what the Space Weather Enthusiast dashboard says. This is NOAA's forecast. Keep in mind, NOAA is a little bit more adverse to false positives, if that makes sense, because it's very costly to prepare satellites for geomagnetic storm impacts. NOAA is expecting geomagnetic unrest to begin around 1500 Universal Time tomorrow on August 4th, and then end sometime around 1500 so about 24 hours there of geomagnetic unrest. We're expecting a second impact late in the day on the 5th. So that just might be because it's not modeled yet. In fact, maybe it is, because there it is. It looks like geomagnetic unrest is showing up there. So expect the possibility of aurora tomorrow night. That is Friday, August 4th, and Saturday night, August 5th. Next, let's take a look at Earth's magnetic moment from space here. Here's our geospace magnetosphere movie depicting the last 4 hours. And we recently did see a shift in the magnetic fields here, so you may see a big increase in the magnetohydrodynamic pressure toward the end of this, just in the past couple of hours there. Maybe not. Looks like it actually decreased. All right, fair enough. Next, our ground magnetic perturbations map. This is Earth's magnetic moment from the ground. We showed it from space. Here it is from the ground. And you may be wondering if I'm worried about Earth's magnetic poles flipping, and the answer is absolutely not. My forecast is that it's going to take another 300,000 years for that to occur. There are the past 4 hours of Earth's magnetic moment from the ground. Next, the KP index, a general average of global geomagnetism, currently only 1.33. Now, again, we may see a little increase in this at the next update, because we did see some magnetic field shifting, which we'll cover next. So KP 1.33 is the current situation for the planetary K index. And here's this shift I was talking about. We saw the magnetic fields increase in strength a little bit, and then a strong negative BZ signal. That negative BZ signal is the vertical component of the magnetic field, which tends to create more induction into the earthly system there. So this could be a little uptick, although it was also accompanied by a downtick in the solar wind density. So current solar wind density only about 3 protons per cubic centimeter. Solar wind speed here 364 kilometers a second. The BT is 7 nanotesla and the BZ is -4. So maybe no uptick coming there, but yeah, we can expect a significant signal sometime after midday tomorrow when the first of 2 significant CME impacts arrives here at planet Earth. Continuing right along to our GOES magnetometer. And we're seeing, let's see, that's higher lows and lower highs there. So more of a tighter range for the GOES magnetometers. Next, the top view ecliptic plane field plot. And like I said yesterday, the South Pole current sheet has been delayed. It might have looked like it was going to arrive as early as today. We're expecting it to be here by tomorrow's daily space weather video. So here's the last image. Sector boundary crossing coming. Earth will be moving to a South Pole current sheet, likely sometime around when we produce tomorrow's video. So as we ramp up to solar maximum, you can expect continued sudden changes happening with the heliosphere. That's the heliospheric current sheet. The top view ecliptic plane field plot, fantastic predictive value in that. If you've never checked it out before, it's part of the National Solar Observatory. We've demonstrated time and time again the predictive value of the top view ecliptic plane field plot on the channel. Next, our line of sight field plot. That is the sun's B field depicted in blue. Photosphere magnetism in grayscale there, and polar fields in green for north and red for south. And that brings us to coronal holes. Coronal holes are super important in that they show us the solar polar field reversal process. Here is our coronal hole line of sight plot. And we've got some mainly North Pole coronal holes here, except for in the northeast. So if you bring up the last image, there's the situation. So we've got some South Pole coronal holes over here, in front of which is the sector boundary crossing, currently like something like this. And then the rest of these are North Pole coronal holes, with a little weak solar southern magnetism down here. So that's pretty much the way the magnetism is currently configured. Again, there is the current image. North Pole coronal holes, except up here, these are South Pole orientation. Sector boundary crossing likely coming tomorrow. Next to sunspots. And let's take a look at our flare monitor and our solar flare scoreboard. All right, so we'll have at least 3 new named sunspot groups likely to show up today. Firstly, this one. That should be 3393. Up here we'll have 3394, and down here 3395. So at least 3 new groups ought to get named today. That is the situation. And let's move on to our fantastic sunspot station. So here is 1600 plus 1700 angstroms. We'll zoom in a little bit closer there to the equator. And then we'll show a close-up of the most likely place to produce a large flare, like an X-class flare. And you can see lots of white on the image there, as it is indeed crackling with solar flares. That is a 24-hour video from the Solar Dynamics Observatory. And that is pretty freaking sweet. All right, so let's take a look at the intensity gram here. Oh, and before we do that, quick note about this ASAP flare monitor system. You see down here it says spaceweather.inf.brad.ac.uk. Well, I checked out the University of Bradford website, and it does explain how the ASAP flare monitor works. Continuum images and magnetogram images to detect the sunspots, then they're grouped and classified, and then machine learning determines the likelihood of solar flare. So we talk about it all the time, that magnetic shear determines the likelihood of a solar flare. And there's an explanation on that if you'd like to read about that at the great University of Bradford Space Weather Research site. Here we're showing August 2nd plus August 3rd to date. Again, at least one new sunspot here, one sunspot here, and one sunspot here. So we'll have a large active group setting here in the next 24 hours. But at least 3 new groups likely to be named and replace that. Besides that, mostly stability here, a little bit of evolution happening over here, and a little bit of growth happening to the north of this sunspot group. Let's move on to things like flares and energetic particles. So we haven't seen any spikes in the GOES proton flux here. No SEPs in the past couple of days. Don't be surprised to see SEPs. Again, because of the high likelihood of large solar flares. Now we have seen the flare profile drop a little bit here. If I bring up the 7-day graph, you can see in the last 2 days there was a big uptick in flaring activity. That has now dropped back down a little bit. It could be the calm before the storm though, folks, so don't be surprised again to see an X-class solar flare. It looks like the background levels have now dropped down to about a C1.9. About a C1.9 background level now. But again, very high likelihood of large flares, especially in the southwestern limb. So let's take a look at our favorite flare wavelengths. Here is 94 plus 131 angstroms. You may see a major plasma reorientation event happening over here. We'll cover that a little bit later in the video as well. Here's a great zoom in on the equator. Now keep in mind, these new groups in the east, they do have the possibility of producing large flares, but at the moment they look magnetically simple. So they look like alpha-class sunspot groups. In other words, beta-class sunspot groups have both polarities. Alpha-class sunspot groups only have one polarity. So, however, it is a large sunspot group, and there is quite a bit of plasma you can see suspended in those magnetic looping features. This will be the place to watch in the next, I'll say the next 48 hours, because keep in mind, folks, sunspots can be associated with huge solar flares even after they've moved out of sight from behind the limb, because solar flares happen in the lower corona, not down at the surface where sunspots appear at the photosphere level. And let's talk about what's going on overhead. So, do you use a star chart? We like to use a star chart, as I like to know what's going on overhead. This is skyandtelescope.org's star chart, and I just find it fantastic. So you've got Venus trailing the sun here. If you are viewing the early night sky, which we might very well be doing tomorrow night, you might get a load of Venus, Mercury, and Mars there in the early sunset skies. If you've got a low horizon and low light pollution, you might be able to see Mercury up there. And let's do a solar system forecast. So this is where things are today. And by the way, leave us a comment if you're viewing the videos from a different timeline, plane of existence, universe, multiverse, planet, starship, star system, etc. Here's your 1 week forecast for all of you Earthlings out there watching the content. That's where things will be in a week. We will have a crescent waning moon as we approach the August new moon phase. And watch out, folks. It's something to be very spooked of. Look, Saturn, Earth, Moon, Mercury, and Mars are all in a fairly straight line, which is, I think that's supposed to be scary because reasons? Pardon the sarcasm. The planets aren't going to kill you. They've been doing what they're doing for billions of years, and you'll be just fine. Saturn, Jupiter, Neptune, the gas giants are not going to kill you. Space weather's not going to kill you either. Although if you're an astronaut or doing lots of polar flights, it could irradiate you. Today's astronomy photo of the day is this fantastic time-lapse image. This is an 8-minute image of a Falcon Heavy's flight. So this is back on July 29th. As that payload gets to the geosynchronous orbit of around 23,000 miles of altitude. So there you go, the astronomy picture of the day, located at apod.nasa.gov. If you're an Elon Musk fanboy, a pathetic sycophant who worships Elon Musk and believes his nonsense, maybe that'll be your new computer desktop. I don't know. So that was Launch Complex 5 at Cape Canaveral. That is it. Again, it's an 8-minute time-lapse image there showing the flight. Okay, wait a minute. The flight of an altitude of 116 miles. Yes, they are the payload is bound for a geosynchronous orbit of 22,000 miles. So there you go. And this in the foreground, that's a Redstone rocket there, which carried Alan Shepard to a suborbital space flight in May of 1961. Moving right along to our coronagraphs. So here is the situation from yesterday. There's 104 frames, including that CME early in the day. Right in there. So that's the one that'll arrive on Saturday, late in the day on Saturday. Friday night and Saturday night, CME impacts here on planet Earth. Don't miss them. And here are today's coronagraphs, seeing if there are any additional CMEs here. Actually, let's go back to yesterday's one more time here. So there's one to miss Earth to the east. Here's one to strike Earth. Most of the ejecta will miss actually to the southwest. And there's a second one that'll also miss to the east. Here are today's frames, 32 additional frames from today. There is an outflow coming out of the south there. I don't expect that to have an earthly directed component. But let's take a look at some more imagery just to make sure. So here are some coronagraphs. The Soho Lasco C2 and C3 together. There is yesterday's CME that will strike Earth. Interestingly enough, there was a significant impact there. You see all those streaks? That is some sort of relativistic particles likely striking the aperture there. Let's also take a look at stereo A. We show this diagram because stereo A and Earth are practically in line with each other, which means it doesn't really help with trajectories at all, but sometimes it includes data that is missing on other coronagraphs. So there's stereo A over on the left. Soho Lasco C3 over on the right. And let's just bring these to the latest images here and move them manually. All right, so we don't expect those to be earthly directed CMEs. No new geomagnetic storms are in the forecast. Just for sake of completeness, we'll also show our 24-hour videos. We do... What happened? All right, there we go. Sorry about that. There is our 24-hour video And right at the beginning, you can see the aftermath of that CME. It came out of this region right in here. And a new filament has formed there since then. So that's always interesting. Filaments form in little channels. And sometimes they'll eject or collapse and then reform. So here's a 24-hour video, just 193 angstroms. And let's move on. And what's next, you ask? Filaments. So we've got massive plasma filaments. Here is the ground-based El Teide, Spain Solar Observatory. So right in here you can see this filament. Part of that is headed toward Earth. That's the one that'll arrive on the 5th. Late in the day on the 5th. And so we've got a really huge number of filaments here. All right, so we've got this one. You've also got this one up here, which I suggested somebody name yesterday on Twitter. You've got this huge crown filament down here, and then another large filament rising over here. So lots of filaments there, and lots of capability to name filaments after your favorite or perhaps your least favorite people. So that's what's going on, and let's take a look at our custom images. Starting with the Northern Hemisphere. So there you go. There's another 24-hour video. Here we've added 304 to the 193 angstroms wavelength to show great contrast to those filamentary features. Again, there is a huge one up here. Let's move to the equatorial view. So lots of filaments. 3 really significant ones on the Earth-facing portion of the solar disk. And here's the southern polar region. You can see a huge crown filament down there. Part of it is a prominence, a great example of how a filament and a prominence are the same feature. Here it's part of this filament hanging over the edge. That makes it a prominence. This part is a filament. This part is a prominence. And we thank all of our prominent viewers for tuning into the channel. Once again, if you want to name filaments after living people, you've got to do it on Twitter. So you can say it in the YouTube comment section, but it's not going to get filaments actually named. Join us over there for hilarious discussions about weather modification, too. People who don't understand that there is no motive, means, or opportunity for chemtrails and... Anyway, you're welcome for facts about meteorology. If you want to name that filament, follow the hashtag #NameThatFilament over on X, the brilliantly rebranded platform formerly known as Twitter. Slow clap on the rebrand, folks. Slow clap on the rebrand. Just brilliant. Here are the past couple of hours from the GO-16 ionized helium wavelength, 304 angstroms. And hey, look, the most active region is down there in the southwest, exactly where we forecasted it to be. What a surprise. And that brings us to our bonus features. Bonus features begin with satellite charging hazards, and we don't have any. It is smooth sailing for satellites here at the moment. No electrons building up on the outside or inside of spacecraft in their geosynchronous near equatorial orbits. GOES electron flux here quite low. Probably anomalous readings there. We did have some geomagnetic unrest conditions yesterday, and the ionosphere is a little puffy. We'll get to that here in a minute. First, the 1-year graph of the electron flux. There you go. Those are the greater than 2 mega electron volt electron flux for the past year. We're in a high to moderate range here. The next update will drop this way down. And you can see quite lower levels here than NOAA forecasted. And you can expect some additional dips here. So, again, 2 CME impacts coming. That will affect the electron flux most certainly as the ionosphere puffs up when those geomagnetic storm conditions happen. So next, the F-flare. This is the layer of the atmosphere where it's measured. Feel free to pause the video on this frame if you're not familiar with distances in kilometers. Here is the F-flare, and we are seeing quite a lot of low-frequency anomalies. Again, we did get into unexpected geomagnetic unrest and minor geomagnetic storm conditions yesterday. If you would have signed up for email alerts from smashomash.com/smashteam, you would have gotten email alerts about it. At first, I didn't send any, but it kept happening, so I sent some. Anyway, that is the vibrational frequency in megahertz, millions of vibrations per second, of the bridge between Earth and space. The F-flare is located at about 300 kilometers of altitude. And if that's all Greek to you, don't worry, we show the anomalygram daily as well. So there's the anomalygram that depicts anomaly in megahertz from a 30-day median. Lots of low-frequency anomalies happening here. That is typical of geomagnetic storm and geomagnetic unrest conditions. Also some perhaps odd high-frequency anomalies happening there. So some rather significant variations happening in the ionosphere, creating big low spots and high spots, essentially. And if you're looking at this area here, that is the South Atlantic anomaly, the weakest point in Earth's magnetosphere. There is a big low spot right there in the ionosphere for sure. It is enduring. It's been there for years. The South Atlantic anomaly over the center of the South American continent. Here's the latest image. That's 11:45 Universal Time, raw vibrational frequency. And there is 12 Universal Time anomalygram. We also show total electron content because it'll show you the most likely place to see GPS errors. And perhaps there is even some predictive value. See our mission again, smashomash.com/forum/mission, about why we like to cover things with predictive value. It's probably obvious. Feel free to pause the video on this frame if you're not familiar with these distances in miles. Here's our total electron content forecast, depicting free electrons between your GPS satellite and your handset. And I would expect to see some significant anomalies here. Let's see. It's actually pretty organized. It's actually less anomalous than it was a few days ago. So we typically do see the highest degree of anomalies under a low electron flux. Again, that is an anomalous reading, however. The low electron flux caused by things like CMEs and coronal hole high-speed streams. That is because the GOES 16 and GOES 18 are measuring the electron flux at the F-flare of the ionosphere. So if the ionosphere puffs up, they're measuring the electron flux lower than where they ought to be, which is calibrated for 300 kilometers of altitude. So there's the total electron content. That is all the free electrons to about 12,500 miles of altitude. And here is the anomaly from 10-day average over North America. And interestingly enough, seeing some significant high electron content anomalies over the Cascadia fault zone. So let's bring that back. There are some recent anomalies around Vancouver Island. Large portions of the North American continent there seeing some high electron content anomalies. So that could be an Earth-based signal there that could foretell earthquakes. I would be on alert for the next 3 to 5 days. I'll say 3 to 4 days, as we've seen an ongoing signal right there. I'll play it through one more time in its full animated glory, and then show you the high-resolution images of the closest star. And thanks for stargazing with us. Here you go. There is the SDO continuum, and there is the SDO magnetogram. So a sunspot formed down here, and it looks like it's already gone. But these two groups will get names. So that looks like it's becoming a beta-class sunspot group there, folks. We'll have to check the polarity of those fields. We do have a leading North Pole umbra showing up there, so that's interesting indeed. Let me try that again. So this is the South Pole umbra. All right, so that's a South Pole umbra there. There's a North Pole umbra there, and that is a South Pole umbra as well. It is now beta gamma class, so it's much more likely to produce a flare than it was even just 24 hours ago. This new group up here, it is still looking like it's alpha class. I only see one umbra there, so obviously only one polarity. And last but not least, this group here, that is the flare player. So that is beta gamma delta class. And a great example right here. You see these little green spots there. That is North Pole magnetism right in the middle of significant South Pole fields. So that is beta gamma delta class, a textbook definition of it. Huge amounts of magnetic shear. You can see right here as well, this back portion. So very high likelihood of producing an X-class flare, especially with its proximity to the solar limb. Here's your full disk rock back. And it's time to move to meteorology. What happened? Here's your full disk rock back. Ah, yes. I'm getting fatigued. I'm getting fatigued, folks. It's too early in the morning to be fatigued. All right, so now we're looking at surface winds and significant wave height. So one of the great features of that's a nullschool.net's Earth wind map, and two tropical systems there in the Pacific. One here right off the coast of China, just north of Taiwan there. So that is, you might think that's the largest waves in the world, but guess what? It's not. The largest waves in the world are actually down here in the Southern Ocean. We've got 37 footers down there. I thought we did. Earlier we did. Well, it's close. We've got 30 plus foot waves in portions of the Southern Ocean. Up here we've got, all right, 36 footers, pretty similar. Also, this spot here is looking like it's pretty beefy. 35 foot waves there as well. That system looking a little bit less organized than the one off the coast of Taiwan. So let's switch to our regularly scheduled surface wind and jet stream maps. We show them daily on the channel. There is the surface wind scenario for the east. There is the jet stream scenario for the east. Jet stream blowing backwards over the western Pacific and northern Indian Ocean. Jet streams of the Americas depicted here. Some more normal temperature weather here moving into the eastern U.S. as cold air moves out toward Newfoundland. A new weather regime is coming to the eastern U.S. Next, surface winds. There you go. Surface winds of the central world. And the jet streams. What's next, you ask? So do I. The Drake Passage. I'm interested in the Drake Passage. It's one of the weirdest places in the world. It's where the Atlantic and Pacific Oceans try to reach static equilibrium. Also known as one of the most dangerous sailing areas. The Drake Passage, the area in between the Antarctican Peninsula and the South American Peninsula. Over here you've got the Pacific, over here you've got the Atlantic. And you got this area right here where they try to reach thermal and pressure equilibrium. Looks like a bad day to be on a boat down there. And here's the full satellite map. As the sun rises over the Mississippi Valley. That is your Planet Earth satellite map from Witty.com. Next, NASA goes Interactive Weather Satellite Suite. Here is clouds and fog over the Americas. And did you know that we often use this image as our thumbnail when we show an image of planet Earth? Yeah, I edit it to the point where it looks like a three-dimensional thing when it's just this two-dimensional image. Fun fact, our thumbnails have more information, more valid, legitimate information on them than entire channels on YouTube, especially the ones who are full of crap. Here's our smoke map from firesmoke.ca, and there is some smoke about to make its way down into the Great Lakes states. Also, lots of fires burning in the U.S., both in the Pacific Northwest and around the east, mainly east of the Mississippi. Again, some thick smoke here moving down through Ontario and so forth. Michigan, Wisconsin, and Minnesota, as well as Ohio and western Pennsylvania, can expect some significant smoke in the coming days. And we've got some significant weather warnings, so let's blast through some of those. Lots of flooding there in the forecast, some severe weather. Weather.gov is where to head if you've got weather warnings. Lots of weather warnings here at the moment. And we're going to show some forecasts related to those next. If your location is lit, just head to weather.gov and get your weather warnings. So first of all, since flooding's in the forecast, we'll show that first. Here is your total accumulated precipitation forecast for the GFS model for the next 72 hours. Check it out. We've got South Dakota and Nebraska, especially also North Dakota and parts of Montana there, expecting some heavy rains of 4 inches. That's your 72-hour GFS total accumulated precipitation forecast in inches. Don't say we didn't warn you. Also, some heavy rain expected for parts of Florida, most of Tennessee. Alabama also expecting some serious rain. Next, your pressure and precipitation forecast based on the same GFS 72-hour model. And here is your jet stream forecast. GFS 72-hour 250 millibar wind forecast. And again, you can see a new bit of jet stream here making its way into the Rockies. Expect clear skies over northern Nevada at the end of this 72-hour run. And there is an anticyclone here approaching San Diego right down here. All right, what's next, you ask? Well, we tell. What's next is the lightning mapper. So some very heavy lightning there, which originated in Missouri, spread into Kentucky, Tennessee, and Illinois in the past about 10 hours. Here's our current lightning map. So south of St. Louis and west of Paducah. Multiple cells there. At least 3 different cells in that area. Also some more minor activity there in Nebraska. Here's your full globe view from lightningmaps.org. Next time you hear thunder, check it out. Or if you're talking to Thor and Odin, tell them that Smash-O-Mash sent you and advise them to subscribe to the channel. Yeah, subscribe to the channel if you're new. Do yourself a favor and get those thumbnails on your YouTube feed. Again, our thumbnails contain more valid information than entire channels. Believe me, we do market research, and there is some nonsense about space weather and geophysics and earth weather and all kinds of things. A lot of nonsense on YouTube, and a lot of people are paid a lot of money to put out utter nonsense. So we also have playlists that have nothing to do with space weather. Check our links on smashomash.com. You'll find all sorts of links there to other social media, even original music. Via the Spotify link, you can find Golden Cat Productions, our record label, on YouTube Music, Amazon Music, iTunes, and all over the place. If you want to support the channel by becoming a member of the Smash Team, that would be optimal. Smashomash.com/Smash Team is our own subscription services site that we created. We launched it back in October of 2021. The best value is the gold annual paid up subscription, as it's almost like getting 4 months of a gold membership for free, because it includes complimentary merch. Thanks to the Smash Team members, these videos are brought to you in part by them, but mainly at massive personal risk and expense by Smash staff and I. So visit the homepage, help us out with clicks if you're unwilling or unable to open your cobweb-encrusted wallet and support the channel financially. Smashomash.com/Smash Team. Welcome to the Neo-Renaissance. Help us complete our missions, which are becoming increasingly difficult due to the economics of the extreme cost and risk that we've created for ourselves by making these videos. Smashomash.com, the homepage. And again, welcome to the Neo-Renaissance. We're going to close out the video with Doppler, clouds and fog, and water vapor. Here's the full 50-state view. Here is the lower 48 view. Some of those storms look pretty serious, especially the ones that are west of Nashville. Yes, pronounce it correctly, folks. You got to say Nashville. Almost like Nolans. It's Nolans and Nashville. You've got to shorten things to sound cool. Here's clouds and fog for the lower 48. You should pronounce the name of places the way the locals pronounce them. Bethlehem, Pennsylvania. Bethlehem, Pennsylvania, for example. Yeah. So one major cloud system there, and you can see rapid rain happening. Basically a line of storms here. It's going to train. So Nashville's going to get plastered throughout the day today repeatedly. Charlotte is in the crosshairs. This is your recap as we close out today's space weather and Earth weather together. Once again, here's clouds and fog. The shortwave radiation map, 3.9 micrometers, and here's 6.19 micrometers. That's water vapor, as in all of it. Clear skies likely over eastern Texas there, as an anticyclone continues to rotate somewhere around, well, it's pretty much centered on Nolans. You see this clockwise rotation happening here, the telltale sign of an upper-level high-pressure zone, known as an anticyclone for the northern hemisphere. Anyway, that is it. We got to close this thing out. Thanks for tuning in. I'm headed back to the bunker because I'm very spooked of space weather. Pardon the sarcasm. I've been consuming a bunch of nonsense on YouTube. While I'm gone, may that solar wind be at your back.